Isn't it painful to build an MCP server from scratch when you already spent a lot of time on your FastAPI server defining all routes with fully typed input and output using Pydantic models? All the information is there, but you somehow need to rebuild all the tools one by one, redefining the input outputs and the logic. Fortunately, there is a better way, and I will show you how you can turn your FastAPI server into an MCP server using a single line of code. Let's go. For the purpose of the example, we define a function called build_FastAPI app that will return a FastAPI application with a few routes. So first, typical stuff here, if you know FastAPI, we create an app and we define two routes. The first route is the root that just returns hello from FastAPI. Then we have the interesting route, weather, that gets a location as a string as input and will return the weather for that location. To do so, we use the HTTPX async client to call a weather API. Then we pass the response and return the result as a JSON. And now here is the magic part. We define a new function, getMCPServer, that defines the application using our build FastAPI app. So here app is a FastAPI application. And then we use the FastMCP library to create a FastMCP server from a FastAPI app, simply by calling fastmcp.fromFastAPI. Doing so, you get an MCP server that supports all the FastAPI routes and is fully compliant with MCP client, with the ability to list tools, execute tools, and so on. Now I will show you a few examples where we use an MCP client to connect to the MCP server and list tools or call them, but also directly integrating with the OpenAI SDK. To make our MCP server work with the OpenAI SDK using the native integration, we need to make our MCP server run on HTTPS. To give HTTPS capabilities to our MCP server, I will use an Ngrok tunnel. So here I create a context manager called Ngrok tunnel, whose job is to create a tunnel before we create the MCP server and to close the tunnel when we close the MCP server. You can use Ngrok freely. The feature is all you need for this kind of use cases. So you just have to provide as an environment variable the ngrok auth token. Also, to be complete, I create a getServer URL function used by the tunnel that will write the tunnel URL to a local file so that later our client can pick up the tunnel URL because it's dynamic. Every time you run an Ngrok tunnel, you get a dynamic URL, except if you have some configuration to have a static domain. Finally, when you run the server script, we first get the MCP server using the getMCPServer function. Then we extract the app from it so we can control the port and run it using UVcorn. So if you have any other plugins or stuff you use in UVcorn, you can use it there. Here I just create a port that is 8888. And finally, we call our Ngrok tunnel and we start the application of the MCP server. Okay, so now let's dive into the client side and show 4 examples. First, listing the tools using the MCP client, calling the tool using the MCP client, then listing the tool using OpenAI, and calling a tool using OpenAI. So here we first get the server URL, getting the URL from the file as we defined before. So it will get our URL generated by the Ngrok tunnel. Then we use the client capabilities of FastMCP to create an MCP client using the server URL. Then we create the first example. So MCP client list tools. Here we just start the client, call the ping method just to check that it works. Then we list all the tools and we display them. I will show you just after the output. The second example is almost the same. We start up the MCP client, we ping to check that it works, and then we call the tool. So the tool is named weather_get. It's the default name generated by FastMCP when it converted our routes to MCP tools. Then we pass the arguments as New York City and we print the results. Now the more interesting parts. We can list the tools using OpenAI directly. So you create a client. Don't forget to have your API key in the environment variables. And then we create a generation using GPT-5 Nano. And here in the tools, you can specify now, using the native capability of the client, an MCP server. So we just give here the URL, and then we ask OpenAI what are the available tools. So it will make a call to our server and then answer with a list of tools that it can use. But you can also call tools directly with AI, otherwise it would not be super useful, right? So we have the last example here, OpenAI Get Weather, where you create the OpenAI clients. And here you ask directly the AI, what's the weather in New York City? And you print the output. Doing so, it will automatically use your MCP server and give back the answer. This is super useful because before you would have to get the tools using the MCP client, convert them to an OpenAI compliant format, and inject the tools in the context using the standard tools definition. But now you can just add multiple MCP remote server and it will work. Though keep in mind that your MCP server must run on HTTP. It must be a remote server, not STDIO, and it must run on HTTPS. So finally, when you launch the client script, it will just parse command line arguments and run the example that you select. Now let's take a quick look at the example in action. So first, we run the server. So I use InPhysical, it's a tool to inject an environment variable in your script. I think I will make a video about it soon because it's really useful. But here, just running our server.py file. Okay, so as you can see, everything is started. We have the Ngrok tunnel up. And if I cut the Ngrok URL text, we get the URL here. So the client should work. Now, I want to run the client with MCP list tools. So if you remember, it's the simple first example that will use the MCP client to list the tools. Here, as you can see on the left, we see all the calls. So the client is interacting with the server to list the list of tools that we have available. Here we get the weather get tool. Okay, now next example. Let's call the weather tool. So here we have the call weather example. And now it will make a call asking for the tool weather in New York City. So as you can see here, we get the raw output, which is not really readable. And that's where the AI is useful because it will parse it in a simple Markdown format that user can read easily. So here, let's first list the tool with OpenAI. So we get the AI model to interact with the MCP server to get back the list of tools. So here, list tools. So we use GPT-5 Nano here, so it's faster and it's okay for this kind of example. As you can see here, OpenAI is making call to our server. As we can see the logs here, it takes a bit more time because it goes through the AI generation to give the answer. And as you can see here, we get the output. So there is the function route that does nothing. And we have the weather route. So here, the weather tools is detected properly. We see the description and so on. So that's cool. It means that we can use it. Now, let's run the weather tool using OpenAI. As you can see, it works. So OpenAI the SDK managed to use our MCP server to call a tool, and we get a nice output here explaining now sunny for today and so on. So very easy and very powerful because from a complex FastAPI that you defined carefully with all the routes and all the input-output using Pydantic, you derive an MCP server in one line, and then in a simple OpenAI call, you get your agent or your AI to be able to call all the tools on your FastAPI server. Keep it. Okay.